Welcome to this IChemE Safety Centre webinar on the importance of process safety. The last webinar we did was with Nancy Leveson from MIT about a week ago, and it focused on how to learn more from your accidents. If you missed it, you can view it at our website. But today we will be discussing the importance of process safety with Mike Connell. Mike is a Principal Safety Analyst with the Major Hazards Program of WorkSafe Victoria. He's a chemical engineer from Melbourne University and had a number of technical and operational roles over 24 years in the petrochemical industry before joining WorkSafe. He joined the authority about 2 months before the explosion at Longford in 1998, and as the only chemical engineer there, was asked to help lead the initial investigation. When the Longford Royal Commission was established, he was seconded to the technical team assisting the Commission. He then became a foundation member of the Major Hazards Unit, which was set up as a recommendation by the Commission. In this presentation, he will talk about how the incident at Longford and its aftermath shaped his growing understanding of the importance of process safety. So I'll now hand over to Mike, but if you have any questions throughout the webinar, please put them in the question panel on your control panel, and we will endeavour to answer them at the end of the session. Thank you.
Thanks, Trish. I was asked about 3 months ago to give a presentation to the Melbourne-based group of the Institution of Chemical Engineers, and that was to mark the 20th anniversary of the explosion and fire at the Esso gas plant at Longford. There was quite a lot being said around that time about the incident, including a loss prevention bulletin by the Institution of Chemical Engineers, and that featured some excellent personal reflections by Trish here, by Mark Donnan, who was responsible for getting major hazard facilities regulations established here in Victoria, and by Bob Weiss, a fellow chemical engineer I had the pleasure of working with at the Longford Royal Commission. The incident at Longford has had quite a strong influence on my professional life since. I think I managed to convey that 3 months ago, and I hope it comes across in this format. First, I'm going to start with telling you what I'm not going to talk about. I won't say much about the direct and underlying causes of the incident and how it came about. That's all described in a lot of detail in the report of the Longford Royal Commission. If, as a result of this presentation, you want to learn more, please read the report. A number of books have been written about lessons that could be learned from that incident. Probably the best known here of all those books would be the excellent work of ANU, Australian National University Professor Andrew Hopkins. Andrew's written a lot of work drawing lessons about safety management system and corporate culture, from analysing the Longford incident and several others. I won't be attempting to cover those areas that Andrew has done so well. And more poignantly, a truly compelling book, Workers' Inferno, was published on the 20th anniversary, and that told the story of the Esso workers who were involved on the day and the effect that it had on their lives and their families. Personally, I found it quite harrowing, and I recommend it to any group such as this audience to see the human cost of process safety gone wrong. I couldn't and I wouldn't attempt to tell their stories. They speak so well for themselves. What I want to focus on today is how what happened at Longford and what has followed since has helped shape my own views on process safety. And I want to tell that from the point of view of a chemical engineer speaking to a group of fellow chemical engineers. And to put that into context, I had been working with WorkSafe, or Victorian Work Cover Authority as it was then called, for barely 2 months when the explosion and fire happened. Friday, 25th of September 1998 is a date I'll never forget, along with so many others at ESSO who have much stronger reasons to remember. At around 1:30 in the afternoon, my boss came to me and said, "There's been a massive explosion at the ESSO gas plant at Longford. You're the only chemical engineer we have here. A team of investigators is about to drive down to the plant. We want you to go with them and do what you can to help them find out what happened." So right from the start, it was recognised that we chemical engineers have the sort of skills and experience needed for investigating process safety incidents like that. In my case, I had worked for about 24 years in the petrochemical industry, on the other side of the desk to where I work now, in a range of technical and operations positions. That was mostly at Altona in Victoria, but also included 5 years in the United States. So I understood process fundamentals. I'd been part of or had led investigations into much smaller incidents than that one. And I'd spent years doing plant troubleshooting work. And I was familiar with the sort of work practices needed when in an operating plant. I'm sure there are many people in this audience better or equally qualified for investigating an incident like Longford. But it fell to me, and I was determined to do the best I could to not let them down. We didn't get very far on the 25th of September. We were stopped by a roadblock that the police had set up about 3 to 4 kilometres west of the plant. We were stuck there with a group of journalists and photographers and some anxious-looking people standing there quietly. I can't say for sure, but I suspect they might have been waiting for news of family and friends at the plant. After about an hour, a police sergeant from the coroner's office arrived. The work cover team was then allowed through the roadblock, but only as far as the heliport across the road from the plant. The fire was still burning fiercely, and entry to the plant itself was forbidden. That shot on your screen there is actually fire coming from the heat exchanger that failed probably around 6 o'clock in the evening. And as I said, the incident occurred around 12:30, many hours later, still burning incredibly fiercely. Because of that, and we couldn't get into the plant, it was agreed that some of the work cover people, including myself, would meet with the Country Fire Authority investigators the next morning at the Fire Authority's regional headquarters in Sale, which is a regional town not far from Longford. And we'd then go down to the plant. This time, we were allowed to go into the plant, but we had to be fully protected in firefighting turnout gear, and we had to stay outside an exclusion zone that may have been as much as 100 metres from the site of the explosion. The fire was still burning on Saturday. We could see some flames, but not as fiercely as on that shot. Yeah. The atmosphere of the place on that Saturday morning is something that I will not forget. By then, it was official that 2 men had been killed, another man was in a critical condition in hospital, and 7 others had been injured, a couple of them quite seriously. The ESSO people that I saw were clearly upset, quiet, and sombre. It was clear to me, from what I was seeing, that process safety is not just something we learn about in textbooks and lectures. It's real, and process safety failures can have a devastating effect on those who lose their lives and also on those who survive. That was my first lesson from Longford. That was reinforced on Monday the 28th. The incident was on Friday the 25th, so 3 days later when I returned to the plant. The fire was finally extinguished on Sunday evening. So we were then able to enter the exclusion zone. On Monday, I saw the extent of damage to the plant and I went into the control room. The time spent in the control room was probably the most confronting situation I had been in up to that time. I was with a couple of work cover inspectors, an arson squad detective, SO's operations superintendent, and two country fire authority escorts. We were there to collect instrument records, manuals, and any other evidence there we could find. It was dark, smoky, and fumy. The power was gone. We had to work by torchlight, but alarms were sounding continuously all the time we were there. And there were clear signs from blankets and blood and burnt material on the floor that injured men had been there. The seriousness of what we were dealing with was unmistakable. The protocol here in Victoria after a major incident like that is that the coroner's office takes charge. The coroner was at Longford on the Saturday morning and he instructed that the police, WorkCover or WorkSafe as it's now known, the fire authority investigators and the forensic squad work together as one team with the police, actually the arson squad, part of the police force, in charge. They planned the investigation, who would be interviewed by who and in what order. The forensic group decided that they needed more technical support and they turned to a professor of chemical engineering at Monash University named Joe Matthews. He in turn looked for someone with more industrial experience. They then approached a talented, enthusiastic process control specialist named Bob Weiss, who was working for Orica at the time. I joined those two, and together our role in the investigation that followed the incident, directed by the coroner's team, was to piece together the sequence of events that led to the explosion and fire. And we were drawing on the witness statements of people at the scene, instrument records, and other evidence that became available. Another team of mechanical and materials specialists worked with a professor of mechanical engineering from Monash University to investigate the cause of the large metal fracture that started the incident. As you probably know, shortly afterwards, the Victorian government set up a Royal Commission to look into the incident. Bob and I were brought into the technical team assisting the Commission, along with some other chemical engineers from interstate and overseas. And we continued working on the chain of events. A lot has been said elsewhere about the Longford Royal Commission, the process it followed, and its conclusions and recommendations. I won't repeat that here, except to say that it was one of the most intense, focused, and exhausting, but ultimately satisfying experiences of my working life. I learned a lot about how to conduct a detailed major investigation like that when time was the enemy, not necessarily resourcing. I'd never before worked closely with police and lawyers, and I gained a lot of respect for the abilities of both groups. And I saw firsthand at the Royal Commission the appalling effect that hostile cross-examination could have on decent men who'd lived through the trauma of that explosion and fire. But back to the theme of this session. What did I learn about process safety? I saw all too clearly the extreme danger posed by catastrophic failure mechanisms, such as low temperature brittle fracture. The glass transition temperature for steel is an interesting technical phenomena when you read about it in textbooks. The reality is much more serious. Those familiar with the details of the incident will know that the direct cause was failure of the weld between the tube channel, the one at the left-hand end of that diagram, and the tube plate. That particular exchanger, pretty standard, straightforward, single pass exchanger, that served as a reboiler for a distillation column. Boiling liquid inside the tubes, hot oil through the shell. When I first saw close up where that weld on the reboiler had split open, it looked to me like the tube channel had been cut off by a giant can opener with very smooth fracture surfaces. It actually took a while before we could get close enough to actually see. When that failed the way it did, and the mechanical engineering study and metallurgical study eventually confirmed the mechanism, that left a huge opening to atmosphere, over 1 metre in diameter. And light ends, ethane, propane, gas, all billowed out at 2,700 kilopascals pressure. Gas and flushing liquid poured out and formed a huge vapour cloud. The consequences were extreme and on that day fatal. I could say a lot more about the direct incident, but I'll leave it at that. What I've learned from that, and what I hope all chemical engineers would take, any process where a high consequence incident is possible, no matter how low its likelihood, must be treated and considered seriously. Please, if you're in a position of dealing with hazard identification and safety assessments, please don't be swayed by some of the arguments that I've heard. Oh yes, I've heard people say, it's a possible scenario, but not a credible scenario. People's lives can depend on you giving serious consideration to all possible scenarios. That's especially important for all possible catastrophic failure mechanisms or any other scenario that has the potential for high consequence events. Don't dismiss anything too quickly. Lives depend on it. One of the recommendations of the Longford Royal Commission was that major hazard facilities regulations be set up in Victoria and an appropriately skilled regulatory unit be established to administer them. I was fortunate enough to be one of the foundation members of the Major Hazards Unit, and I'm proud of what we've achieved since then. Obviously, I can't name specific companies or go into specific details of failures, but I have seen some facilities that I thought were potentially huge problems turn themselves around. And they've become, as a result of the regulations and the processes involved, they've become what I think are well-run, reliable and safe facilities. It usually took management changes and a lot of effort by the companies and their employees to actually bring about those changes. But I'm pleased with the role of the Major Hazards Unit at WorkSafe, pleased with what they've been able to contribute to that role, principally in encouraging companies to change. That often involves just holding a mirror up to companies and putting whatever pressure we can legally apply on them to make the necessary changes. But in the early years of the Major Hazard Facility regime, I also spent some time as part of the ESSO prosecution team that took ESSO to court. And as a result of that, had ESSO found guilty of 11 charges under the Occupational Health and Safety Act. It was a small team led by Robert Richter QC, a man with a stunningly brilliant mind, and his so-called junior, Neil Cleland, now a highly respected senior counsel in his own right. We had an experienced WorkSafe solicitor, Stan Krapan. He carried most of the instructing solicitor load with some extra legal support from a senior solicitor from one of the commercial firms in Melbourne, Arnold Bloch Liebler. And I provided advice on technical matters to the team. Quite a small team, but successful. Court trials are highly adversarial and the outcome quite uncertain until the verdict is given. In this case, a jury of 12 ordinary citizens were convinced beyond reasonable doubt that Esso was guilty of all 11 charges. I thought the Longford Royal Commission was intense hard work. That was nothing compared to the work involved in supporting the Esso prosecution. Late nights, lots of weekend work, and all the time a voice inside me saying, don't let the team down. Help bring some justice to the people caught up in the tragedy at Longford. I learned so much from working with that team, watching and listening to top lawyers strategizing. And the morning the jury returned its verdict was one of those moments that I won't forget. But the thing I took away from that trial that's relevant to this session is that process safety matters. Safety regulation is criminal law. A breach of health and safety is a criminal matter. One of the many reasons I was pleased with the outcome of the trial is that it reinforced the importance of obeying those laws. To my knowledge, the fine imposed on Esso is still the highest fine that has been imposed in Victoria for health and safety breaches. I sincerely hope that nothing worse than the Longford incident ever happens here that could incur a bigger fine. I've learnt a lot also in my time working with the Major Hazards Unit at WorkSafe. I thought, after working for over 20 years in the industry, that I knew just about all that was needed to be known about process safety. I realised after a year or so with the unit that I was learning so much more. I think I've gained a much better appreciation of risk, consequence and likelihood through seeing lots of different situations and lots of ways of approaching them. A simple example familiar to most chemical engineers is the use of HAZOP studies. I was one of the first people at a former workplace to be trained in leading HAZOPs quite some years ago. One of the practices back then was to rule out from further investigation possible scenarios that were, quote, double contingency. I now understand that if the possible consequences are severe enough, you can't simply rule out double contingencies. You may need to do a much more sophisticated risk assessment involving detailed consequence and likelihood analyses. It's noticeable that more and more facilities now have some form of LOPA study as part of their safety assessment process. And on a related matter related to LOPA type analyses, I've seen that many facilities discount the likelihood of people being injured as a result of an incident. They discount that by including an exposure factor in their calculations. The argument they use is that if a plant operator is only likely to be at a particular location for a small fraction of the time during the shift, for most of the time, if an accident were to occur, no one would be injured. Hence, the probability of a fatality occurring can be discounted. In some cases, I've seen by up to 2 orders of magnitude. The Longford incident shows the problem with this approach. The 2 men who were killed and the others who were injured were not there as a result of randomly walking around the plant. When things go wrong, people gather. I always ask questions when a safety assessment relies on an exposure factor to reduce the probability of fatality from an incident to below a target. And they use this to justify no further risk reduction is needed. And a final thing I want to say about how WorkSafe's major hazards personnel work is anyone in the audience who's working in a major hazard facility in Victoria will know that WorkSafe assigns oversight teams to each major hazard facility. And that consists of a specialist major hazard facilities inspector and a process safety analyst. When the Longford Royal Commission made its recommendations, the government of the day that accepted the recommendations to set up a specialist major hazards unit, and WorkSafe began the process of recruiting a team of safety analysts. Shortly after, there was another state election and a change of government. The new government agreed to the establishment of that major hazards unit, but with a change. I won't attempt to comment on why government made that change. That's a government level decision, and someone like myself has no involvement at that level. But as a result, a group of specialist inspectors was recruited in 2000, and we've maintained that practice in WorkSafe Victoria ever since, of working in teams. In my opinion, that practice has worked really well. It's not strict demarcation, but the inspectors tend to work at the higher frequency, lower consequence end of safety management, while the safety analysts focus on the lower frequency, higher consequence end of process safety. And when it comes to recruiting process safety analysts, where do we usually find good candidates? Among people like you, chemical engineers, who have the knowledge and skills to make a difference in process safety. You can make a difference in your present role, whether it be in design, technical support, operations, or management. If you have a design role, please exercise it to push for inherent safety solutions, not just adding extra instrument controls. And as on the slide in front of you, inherent safety is something promoted quite strongly by the Institution of Chemical Engineers. And do you know, that's exactly what ESSO did when they rebuilt the lean oil equipment in that gas plant after the incident. They opted for low temperature resistant equipment, not just additional low temperature trips. That's the way to go. If you have an operations or a management role, what level of process safety do you look for? Is relying on procedural controls really good enough? Ask yourself those sorts of questions. I think another vitally important area is the suite of activities that make up asset integrity. Things such as critical function testing, pressure vessel inspections, pressure relief, and fire protection equipment. At WorkSafe Victoria, we are seeing a trend in the tough manufacturing environment in Australia of pushing the envelope, such as using risk-based inspection techniques to extend the time between inspection and testing of safety-related equipment. We recently saw a case where a major hazard facility said that by using its risk-based inspection methodology, it could defer an internal inspection of some equipment for more than 50 years after the previous internal inspection. More than 50 years. And that's called asset integrity. If it falls to you in your role to make a decision like that, please remember that process safety matters. The lives of your fellow workers and the well-being of their loved ones can depend on design decisions and operations management decisions that are made at major hazard facilities. So I appeal to my fellow chemical engineers listening to this. If it falls to you in your role to make these sorts of decisions, be a champion for process safety. Always err on the side of process safety. We never want to see a major incident again like the one that occurred at Longford 20 years ago. Thank you.
Thanks for that, Mike. So if anyone's got any questions, please feel free to type them into the questions box and I'll put those to Mike. But one of the things that I just wanted to raise, having listened to that presentation by Mike, was one of the other outcomes of the Longford Royal Commission was to put in place some sort of oversight on the regulator as well, to make sure that they were holding up their end of the bargain in regulating the safety at facilities. And that ended up being adopted as the Major Hazard Advisory Committee, a committee that I was then privileged enough to serve on behalf of industry for some 7 years in previous roles, which I really found fascinating in focusing on making sure that not only were the companies trying to do the right thing, but also that the regulator was as well. I think that was quite important, especially for me, given in my career, Longford was actually the triggering event that led me to process safety. So I remember that day, the 25th of September. I was working at the Altona refinery at the time. I was the coordinator for all the offsites and pipelines coming into the refinery. And we got a phone call to say that the pipeline was being turned off from Longford. And I so clearly remember walking into the control room, turning on the radio and listening to the media talking about 2 people being missing. And that still sticks with me today on that particular day. So based on that, being Longford effectively my trigger of why I now work in process safety, Mike, how did you first become interested in process safety?
I suppose it's really interesting. I was a typical engineer for many years, interested primarily in building stuff, designing stuff, seeing concrete appear in front of me. Then at some point, and I can't say exactly, I was still working in industry, I started to read more and more about some of the publications that were coming out. People were publishing studies on the impact of a levee. And I remember at the time reading one. It was a fairly simple model for predicting the outcome. And I was working in a place that had 3 big spheres of C4 material at the back. And I said, let's try this. How far would the impact of a levee on one of those go? And calculated, is that right? Took another look and said, oh my goodness. I then started to become more and more interested, and I looked at things like an ammonia refrigeration system that we had. If we had a release on the downstream side of the compressor of liquid ammonia, how fast could it come out? How far could the toxic effects go? Oh my goodness. More and more, as I started to see this, I said, this is really quite serious. And then seeing the effect of, not as serious as Longford, other incidents, and the effect it had on fellow people I worked with. I did spend, I had the opportunity of working on shift for 1.5 years to nearly 2 years. And I'm well aware of the bonds that develop between people working shift. And you see the effect that it has on people when one of their mates is seriously injured or worse. So putting all that together, I became more and more interested, and I worked progressively more in implementing some of the safety management systems, I guess I still didn't have the, it took a while for me to appreciate the continuum of low consequence incidents, slips, trips, falls at one end, and high consequence, low frequency incidents, process safety at the other. It just grew on me over a number of years. Don't know if that answers the question, Trish.
No, I think that's good. Thanks, Mike. So I've had a couple of questions come through now from our audience as well. So are there any regulatory requirements in Australia to specifically consider inherent safety during the conduct of a process hazard analysis?
Not as I understand a process hazard analysis. Look, the overriding obligation in Victorian and Australian OHS regulations is to reduce risk so far as reasonably practicable. Clearly, you can do far more reducing the risk when you are at the design stage. So we would expect people to be able to justify in greenfield sites and early design why they have chosen certain routes. Once a facility is there in place, as far as reasonably practicable, it is harder and harder to justify major changes to your basic process technology. I think we all know your basic process technology sets your fundamental risk profile. And after that, there's sizes of equipment and location and factors like that. And further out, you've got safety systems and right out at the end, procedural controls. It is harder to justify getting further and further into the design. We don't, that I'm aware of, require people to justify in their analysis of an existing facility, why haven't you gone to some completely different technology?
Okay, thanks for that. I've got another one here. Thanks for sharing your insights on process safety, Mike. As a younger process safety engineer, I've been fortunate to not have been directly involved in a major accident. What would be your key message on process safety to those of us who are starting to move into roles of responsibility and influence in design and operation of major hazard facilities?
That's a really good question. I think what I would suggest is have a good look at what really happens in the facilities you're working in. One of the questions that I often ask when I visit a site, because I'm a regulator now and not tied to one particular or plant or group of plants, I often visit new facilities or places I haven't been to before. One of the questions I ask most often to try and get a feel for it, I just ask the first few people, what's the worst thing that could happen here? Think about that and then look into, how could that happen? What's the fundamental underlying design basis for so much of this? What does control of safety really rely on at this particular facility? And as you start digging, you'll find out what's really critical. Is it a fundamental pressure control regime? Is it particular pressure control system that leads in? Is it a whatever? The only way you will find out that is to actually talk to people, particularly experienced people, and that can include the plant operators as well. Really ought to cultivate them and read as much as you can about the design basis and design manuals.
Okay, thanks for that. As part of continuing the demonstration of so far as is reasonably practicable, is there a way to adequately assess if SFARP has been achieved or not?
it's a fairly convoluted argument, isn't it? Interestingly, when Victoria looked into the Occupational Health and Safety Act in around 2004, 2007, the authority commissioned a leading administrative barrister to do a very thorough review. And I heard from a presentation from this, he's now a judge, was, look, early case law, practicable and achievable were considered about the same. So if it was possible to do something, it was considered practicable. I guess that was just too much of a tie, too much of an obligation. So what evolved, and I'm talking, previous century, was this fairly convoluted argument in response. Yes, when you are considering is something practicable, you need to consider those things that are spelt out in the Act. What you know, what you ought to know, what the likelihood, what the consequence is, has it been done, and finally, a sort of cost-benefit effect. Are you at the point where if you go to a lot of that, putting further changes really doesn't give you any benefit? The law in Australia is very much not specific. It doesn't say you must get the risk down to a certain numeric target. It doesn't say you must put in the control measures as specified by corporate standards or whatever. What it says is that you have the obligation to think really seriously about this. Is it practicable? Can you do more? Will you achieve a benefit that isn't disproportionate to what it would take? And I have seen cases where people can get tied up in lots of numerical quantified arguments. I know the authority I work with, we're not looking for that. We're looking for you to establish a case that we have got to the point where, look, there's always better things you can do. You can always do more to improve, reduce risk and improve the situation. But you are required under major hazard facility regulations to show, I really have got to the point where I'm reducing risk as far as I reasonably can, given that balance and trade-off. Show this by examples, whatever. Okay.
Thanks, Mike. Yeah, that is a very complex question that many people struggle with wherever this sort of regime around the world has been implemented. What's your opinion about the hazards that may result after a management of change in an operational facility?
Well, I think the history shows so many incidents have followed inadequately thought through changes. Yeah, it's absolutely vital. I suppose an incident like Flixborough started off so much of the thinking that people have now on process safety, and that was management of change. It's absolutely vital that change be well and truly considered, thought through. That means that the people who are reviewing have to know what they're talking about too. And that's really the important thing. Make sure in any change review that you've got people who really do know their subject, and that you're covering all the subjects, that if we have a range of people. I don't know if I've answered the question or not, but they're the sort of things that I'd look for.
Okay, thanks for that. From my perspective, I guess the Longford Royal Commission led a substantial change in the legislative environment within Victoria, which then permeated through to the rest of Australia under its now harmonised laws. And then following the Pike River tragedy in New Zealand, where they had a Royal Commission, they then adopted the Australian regime for managing of health and safety over there, including major hazards. In these days of Royal Commissions, we seem to be having a lot of them, and it's almost now government by Royal Commission, I think, in Australia in a lot of ways. I'm losing count of the number that we've had recently. Do you think the Royal Commission is a good way to do an incident investigation?
That is quite a good and difficult question. There are a lot of, look, the power of a Royal Commission is that you can compel witnesses to give evidence, that you have to answer the question. It's, as you just said, Trish, we're having lots and lots of Royal Commissions right now, so it's quite topical. Back in 1998, 99, there was nothing like that. Depends how you rate good. It was a good way in that it did get to the bottom of the incident. I guess it was awfully expensive too. People, companies, ESO have legal rights, so it is absolutely right and perfect that they be represented and have adequate legal representation. But the end result of that is that it takes a long time and costs a lot of money to get to the answer, but it does get to the answer. So it's good in the sense that it gets to the answer. You've got tremendous resources available. Heavens, it's a time and money intense process to do it.
Yeah, I think that's probably its biggest drawback. The other advantage it has, though, perhaps, is that because it's aimed at getting to the bottom of what occurred, as opposed to investigation for prosecution, there is you start from a different perspective. Your perspective is, what can I learn, as opposed to what was the breach of law I can prosecute, which is quite a different focus. And I think for me that is one of the values of the US Chemical Safety Board, for example. Their whole remit is, what can I learn, not what can I see was a breach to prosecute. So I think that does have some examples there. Another question here: sustaining and enhancing process safety culture within an organisation is an ever-challenging element. What are your thoughts about the attributes of a sound process safety culture?
Oh, I don't know that I can sum that up in one neat sentence answer. I would expect an organisation with a good process safety culture would always be looking at what can go wrong here, what can I do here. The process safety, when I can remember hearing people use phrases like, it's not rocket science. It comes down to understanding what can go wrong, how it can go wrong, and what can I do? What am I relying on? So I would expect a company with a good process safety culture to always know and understand what they're relying on to prevent things go wrong. That's the sort of, and how do you recognise that? I suppose you recognise it by when you ask simple questions like, gee, what can go wrong here? What is it you're relying on? And if people can actually answer that and articulate that clearly, then I would expect that there's some good things happening in this company.
Thanks for that. I think, from the perspective in the ISC, one of the things we talk about in terms of what a good process safety culture looks like follows Dr. James Reason's 5 elements. Informed, the relevant data is collected, analysed, and safety information is actively disseminated. A reporting culture where reports are acted upon and people confident that they can report without fear of retribution. A learning culture where the organisation learns from its mistakes and makes the necessary changes. A just culture where errors will not be punished if unintentional, but willful deliberate acts will have consequences. And finally, flexible, where people are able to adapt effectively to the changing demands. And I think that does pick up that, what can happen here. That's all part of the learning, the reporting, the informed part, and then dealing with the outcome really brings in that just and that flexible part of it as well, and the learning.
That addresses the cultural part of that question much better than what I did.
No problem. Okay, Mike, you appear to have a slightly dim view on risk-based inspection to manage inspection requirements, but isn't this work done based on studies about understanding the risk of the damage mechanism and inspection accordingly, not just on a periodic time basis, hence reducing the risk?
It may, if that comes across as a dim view, look, I remember when risk-based inspections, the whole approach was first introduced, and it led to a lot of significant improvements in operations. If I'm expressing a dim view, if I appear to be sounding that way, it's probably as a result of what we are seeing now. We think the envelope is perhaps being pushed past the origin. What you just said in that question, understanding degradation mechanisms, etc. I know that the risk-based inspection approach was introduced for optimization. Appears to be all the one way of what we're seeing, which is why we're starting to challenge it. We would expect, if it's optimized, that there would be a number of examples where time between inspections, or whatever the aspects that are inspected, that actually the times would get shorter, the durations of inspections would get longer. That's generally not what we're seeing now. Hence my somewhat black hat view of it.
Yeah, I think that's a challenging one, that if you've got the data and the information and you can actually go through and determine that this is an appropriate inspection time based on the degradation mechanisms, then it's a good thing to do, because the more startups and shutdowns you have, the more risk you introduce, all these sorts of things. But I'm familiar with organisations in the past that have built a tank, and before they even did its first internal inspection, tried to use RBI to extend its internal inspection. They had no data to start with. All they had was a brand new tank. So understanding, its intent, I think it has some very valuable uses, but it also has the opportunity to be misused, I think, perhaps as well. Okay, well, thanks for that, Mike. I think it was a really interesting session. We greatly appreciate your time, taking the time to share with us today. For those of you listening, just to let you know, we have another couple of upcoming webinars. On the 11th of April, US time, Eastern time, at 3 p.m, I will be discussing due diligence in process safety. This is a webinar series hosted by Chemical Processing magazine. It was previously a series that was hosted by Dr. Sam Manan, and I have agreed to fill in for one of those. So you can register at that link on the screen. We also have then John Breslin, who's a former chair of the US Chemical Safety Board, talking about control room competency on the 17th of April at 8 p.m. Australian Eastern Standard Time. So you'll all be sent links to your company for registering for that particular webinar. All of our webinars are also available on our website, and this one will be posted shortly. So you'll be able to actually review this webinar if you wanted to look at it again or share it with others. So at the link on the bottom of the screen there will take you straight to where all the webinars are actually stored on our website. So once again, I'd just like to thank Mike for his time and wish you all a safe day. Thank you very much.
And thank you, those who've taken the effort to listen. I always appreciate the opportunity to talk about the importance of safety. Thank you.
I'll just